We've talked about the atmosphere already, but thus far we've only described it as the gaseous layer surrounding the solid Earth. Most terrestrial life lives in the atmosphere to some extent or another, and all life depends on the atmosphere for survival. So, it merits some deeper discussion. The atmosphere is a gaseous mixture composed of primarily nitrogen, actually almost 78% of it. Nitrogen is an essential nutrient for life on Earth, but not in this form. For the most part, this 78% goes unused by most of the life on Earth. We just inhale and exhale it without making any use of it. The part of the atmosphere that we as humans make the most direct use of is the approximately 21% that is composed of oxygen. Since the atmosphere is a mixture, these numbers are averages, and what occupies the remaining 1% tends to fluctuate. In general, it is comprised of carbon dioxide, water vapor, and trace amounts of some other compounds such as argon, methane, or sulfuric acid. It is important to remember that air, the atmosphere, is not nothing. Even though we walk through it with little resistance and usually can't see it, it is full of matter. It is a mixture of gases that has both mass and weight. When you look up and can observe the color of the sky, you are observing the waves of light being scattered by the particles in this giant gaseous mixture. If you hold your hand out the window of a moving car, it is pushed back because it's being pushed by the air the car is moving through. Since the atmosphere has mass, it is also pulled down by gravity, has weight, and presses down on anything beneath it. This is why atmospheric pressure is greatest closest to the surface of the Earth, because there is more air above and thus more mass with weight pressing down. It is actually a very dynamic mixture, broken down into different layers such as the troposphere, stratosphere, mesosphere, and thermosphere, each with their own composition and properties. Living things constantly change the atmosphere, change the chemical composition of the atmosphere, pulling out gases and putting new ones in. Several of the notable biological processes that influence the atmosphere are cellular respiration, photosynthesis, nitrogen fixation, and decomposition. During cellular respiration, organisms take oxygen into their bodies and out of the atmosphere while trying to metabolize sugar. They then release carbon dioxide to the atmosphere as a byproduct. During photosynthesis, the opposite happens. Organisms take carbon dioxide into their bodies and out of the atmosphere to produce sugar. They release oxygen into the atmosphere as a byproduct. During nitrogen fixation, certain bacterial and fungal organisms take nitrogen out of the atmosphere and turn it into nitrogenous molecules that the other organisms can use. Finally, during decomposition, decomposed organisms, mostly microscopic organisms, break down dead organic matter and return some nutrients to the ground, but also release some back to the atmosphere. The actual solid Earth beneath the atmosphere also does several things to influence the atmosphere. Some examples of these processes are fires, which put carbon dioxide and other gases into the atmosphere, volcanoes, which release carbon dioxide and sulfuric gases into the atmosphere, and evaporation, which turns liquids, mostly water, into gases and allows them to enter the atmosphere. Humans impact the atmosphere possibly more than any other type of organism, including plants. Our use of fossil fuels for energy releases carbon dioxide and other greenhouse gases into the atmosphere. Further, as our population expands and we cut down more forested land, the amount of photosynthesis taking place on Earth, which takes that carbon dioxide out of the atmosphere, decreases, together causing humans to have a massive impact on the oxygen-carbon dioxide ratio in the atmosphere. Other pollutants, such as CFCs or chlorofluorocarbons, which block the ozone layer's ability to absorb dangerous solar radiation, can have additional dramatic effects. Why do we need the atmosphere? First, it protects us from the sun and maintains the temperature on the surface of the Earth. Second, our bodies need chemical ingredients only found in the atmosphere. The oxygen that most living things need for cellular respiration comes from the atmosphere. Carbon dioxide that plants need for photosynthesis to produce the sugar that all life needs comes from the atmosphere, and the proteins that make up and differentiate the bodies of all living things come from nitrogen atoms found in the atmosphere. When the atmosphere changes, the appearance and physiology of life has to change. The fossil record holds evidence of this. Another reason that we need the atmosphere is that it controls how solar radiation enters and leaves the Earth, which is vital to Earth maintaining a range of temperatures from day to night and from winter to summer that supports life. When radiation from the sun hits the Earth, some gets through the atmosphere and comes down to the surface and provides heat. Some bounces back out through the atmosphere to space. Certain compounds in the atmosphere, such as carbon dioxide and water vapor, are greenhouse gases, and bounce some of that rebounding energy back to the surface of the Earth. We need this to happen to a certain extent, to keep the Earth from getting too cold at night when we no longer receive solar radiation. However, when there's too much of these gases in the atmosphere, there's too much insulation, and too much heat stays within the atmosphere, similar to wearing a sweatshirt in the middle of August. When the temperature on Earth changes even a couple degrees, oceans and atmospheric currents can become less stable and weather patterns can become more and more dramatic and dangerous. If the ice at the poles melts, the loss of that shiny reflective surfaces causes the Earth to absorb even more heat. So, to wrap up our discussion of the atmosphere, what is weather? Basically just the atmospheric conditions at any given point in time, which is controlled by the temperature, atmospheric pressure, moisture, and movement of the atmosphere, which in turn are controlled by the same things that influence climate. When they change, weather changes. We are just dealing with a more immediate timescale than climate.